Welcome back to our Unity Roguelite tutorial series. In the last few videos, we've been working on procedural dungeon generation. First, we started with a binary space partitioning algorithm to place our rooms. Then we generated our hallways, and finally, we created our walls. Today, we're going to explore an alternative dungeon generation algorithm, room placement with tunneling, which is going to be the approach that we use for the rest of this project. So let's start by creating a new C# script in our dungeon generation folder, and we're going to name it BSP Dungeon Generator. Okay, we're going to go ahead and open up both of our dungeon generation scripts and our BSP Dungeon Generator script, and we're going to go ahead and we're going to cut all of the logic from our dungeon generator and paste it into our BSP Dungeon Generator. Let's go ahead and grab all of our stuff from in there, and then we'll go ahead and paste it inside of this class. And then we're going to need to import some of these usings. So we'll need to say using system.collections.generic. And I think that's going to clear up everything. Yep. All right. That looks great. So then we'll go ahead and save that script. We can actually close this out. We're not going to need to edit it any further. And then we'll go ahead and save our dungeon generator. We can remove all these extra usings that we're not currently using because we're going to use some different ones. Okay, so now that we've got that, let's go ahead and create a new script inside of our dungeon generation folder. So we can do that in our file structure here. We'll just right click, say new file, and we're going to name this room.cs. And inside of our room, we're going to create our class, and then we'll call it room, and then we'll close our file explorer here. We don't need that open. Okay, so in our room, we're going to define some of our properties. So first, we're going to define where the room is. So we'll use a x and a y coordinate for that. So we could say public int x, public int y. And then we'll also have our height and our width of our room. So let's add those, public int width and public int height. Okay. Next, we'll also add our constructor. So whenever we create a new room, we can just pass these values in, and then it'll automatically set up a room for us. So we'll say public room, and then we'll have an int x, int y, int width, and an int height. And then inside of our constructor, we'll use the this keyword to make sure that we're setting up our local variables, our member variables with the new passed in values. So say width and set that equal to width. And lastly, we'll set up our height. All right. So this class represents the individual rooms in our dungeon. The x and the y variables are going to store the top left corner of the room, and the width and height will define its size. We'll use this to create and manage our room placement. So next, we're going to add a function to check if our room is intersecting with another room, and this is going to be useful later when we're doing our room placement logic. So let's go ahead and add a public boolean. We'll call this intersects, and we're going to pass in a room, and I'm just going to call this other. So this function works by comparing the boundaries of our current room with another room. If any of the edges of the current room are overlapping with the corresponding edge of the other room, then they're considered intersecting. And by ensuring that these checks fail, we'll guarantee that the rooms are placed without any overlap. So let's go ahead and return our value. And then we're going to add our logic here for checking. So first, we're going to check if the current room's left edge overlaps with the other room's right edge. So we'll say x is less than other dot x plus other dot width. Okay, then we're going to go ahead and check our left edge with our right edge with their left edge, So x plus width, and then we'll say is less than or greater than, other dot x. Okay, Next, we'll check our Y. So we'll check if our top edge is currently against or overlapping their bottom edge. So we'll say Y is less than other.y plus other.height. And then we'll say y plus height is greater than other.y. All right. So then, now that we've got that, we'll go ahead and also set up some settings in our dungeon generator. So first, let's define the variables for our dungeon dimensions, room constraints, and tile characters. So we'll go ahead and we'll add a height and width, for our dungeon. So we'll say int, and then dungeon width. I'm gonna set that one equal to 50, and we'll say dungeon height. I'm gonna set that one to 30, and then we'll need to determine how many rooms that our dungeon should have. So we'll create a public int for that. I'm just gonna call my nums rooms, set that to 10, and then we will need a minimum and a maximum room size. So this will help us randomly determine how large our rooms will be, making sure that we don't exceed either of these values. So I'm going to set the minimum room size to 3 and create a max room size. Set that one to 7. Okay, next we're going to add our tile character. So we're going to do this as a private variable. These are going to be characters, so they'll say char, and then we'll have a wall character. And this is going to be a pound sign. And then in case you haven't used characters before, when using a character, you need to use these single quotes instead of the double quotes, because double quotes are associated with strings, where the single quotes are associated with a single character. So if you use the double quote, it's going to give you an error, and it's not going to like that. So make sure that you use these single quotes here. Okay, so let's add our floor char as well. Okay. So the dungeon width and dungeon height variables will determine our grid size. The number of rooms will set the number of rooms that we want to generate. And then the minimum and maximum room ensures that the rooms are not too small or too large. And then the wall and floor char define our visual markers for the walls and floors in our dungeon grid. So next, let's create a method called initialize dungeon. So this is going to be a private, and this is going to initialize our dungeon for us. So we'll say initialize dungeon. And we're going to create our 2D array in here. And we're actually going to return this. So we'll return it right after we finish initializing it. So we'll say new char. And then we're going to use our dungeon width for our width, and our dungeon height for the height of the dungeon. And then we'll go down a few and we'll say return dungeon. And then before we return this, we're going to loop through every position in our dungeon, and we're just going to initialize it to be a wall. So we'll loop through our X. So we're going to go until we reach our dungeon width. And then we'll say X++, and then we'll go on our Y, and we're going to go until we reach our height. Okay, and then Y++. Okay, and then we'll just initialize this position to a wall character. So if we were to visualize this right now, it would just make every single position in our grid a wall. And then when we generate our rooms, we're going to carve our rooms out of the walls. So we'll just change the ones that we need to be a floor tile, leaving all of the rest of the tiles to be wall tiles. All right, so now let's go ahead and create our entry point into our dungeon. We will create a public void called generate dungeon. And we want this to be the same as it was before, the generate dungeon, because our editor script is still going to work with this script as long as we still have the scripts that we need to have, or the methods we need to have in order to make it work, which is this generate dungeon function. So in here, we're going to create our character array, 2D character array. We're going to call this dungeon. And I'm going to set this to initialize dungeon. All right, so next we're going to add our generate rooms method. And this is going to return a list of rooms. So this will contain our room object, and then we'll call it generate rooms. And this needs to take in our dungeon so we can see like where we're putting our rooms. So let's call this dungeon. All right, so then the first thing we'll do is we'll create the list of rooms that we're going to return. So we'll just call this rooms, and we'll set that equal to a new list of room. And then we'll also create a random object so we can randomly select our room size and our position as well. So new system.random. All right, so first we're going to loop through the number of rooms that we intend to create. So we'll start at 0 and we'll go until we hit our number of rooms that we defined as a setting, and then we'll just increase this. Okay, so now that we're looping through the number of rooms, we're actually going to allow our algorithm to try a few times to place a room before it gives up placing a room. So we'll create a for loop for that, and we'll set int attempt equal to 0, and then we're going to continue until our attempts reach a number of attempts. So I'm just going to use 100 for simplicity right now, but you can use any number you'd like here. However many attempts you want to try, you can say that. Then we'll increase this. So this is going to give us the best chance at creating the maximum number of rooms that we can given our rooms constraint. So you can use any number that you'd like, but I'm going to use 100. This will try 100 times to place a room before it gives up. That might be too many, but for now that'll be good. And then as we're testing, we can tweak that. All right, so now that we have our attempts, we'll go ahead and generate our room. So first, let's determine how big our room will be. So we'll choose a width and a height. So let's say int room width. And then we're going to use our random.next. We'll choose a width between our minimum room size and our maximum room size. Then we're going to use our room height in the same way. So min room size, max room size. Then we're going to choose where the room exists in our dungeon. So let's go ahead and choose a room X. So this is also going to be chosen by our random.next function, but instead of using our room size, we're going to give it some numbers that it can choose from. So first, we're going to pass in the number 2 as our minimum, and this is going to ensure that we are at least 2 tiles from the edge of our dungeon. And why we're doing that is so that way we have, so we'll have 2 tiles buffer between our floor and our edge. And when we create our wall will have a 1 tile buffer. And that'll ensure that all of our walls are generated correctly without having to worry about like out of range exceptions for checking the neighbors on the edge. Okay, and then we're going to do the same thing for the other side. We're going to give it a 2 tile buffer. So for our maximum, we're going to choose our dungeon width, and then we're going to subtract our room width, and then we're going to subtract that 2 tile buffer. And then for our room Y, we're actually going to use the same except for our width and height. Our width will be height instead. So we'll say next 2, and then dungeon height minus room height minus 2. Right, so then we'll go ahead and create our new room. So we'll say room, new room equals new room. And we'll pass in our room X, our room Y, our room width, and our room height. And now we'll go ahead and set up all of our variables inside of our room. Then we're going to go ahead and check if we intersect with any of the rooms that we already have added. So let's go ahead and define a local Boolean called intersects. We're going to go ahead and set this to false initially. And then we're going to loop through all of the rooms we've already created. So for our first one, this won't loop through anything. It'll just add the room. But for any room after that, it's going to check if it intersects with an existing room. So inside of our for each loop, we're going to check if new room dot intersects, and then we're going to pass in the room that we're currently looping through. And if it does intersect, we'll say intersects equals true. And then we're going to break out of this for each loop because it doesn't matter if we're overlapping any of the other rooms. We're overlapping one, and that's enough for us to try again. Okay, so then after for each loop, we'll check if we intersected with anything. So if we didn't intersect with anything, then we can go ahead and add the room to our rooms list. Here we go. Okay, so now that we added our room, we'll need to go ahead and loop through our room and add the dungeon coordinate to be a floor instead of a wall. So to do that, we'll say for, and then we'll loop through our X, but we're going to start at our room X. Then we're going to loop until we reach room X plus our room width. And then we're just going to increase that X each time. Then we'll also need to loop through our Y position. So we'll say int Y equals our room Y. And then our Y needs to be less than our room Y plus our room height to keep going. And then we will increase our Y. So then from here, we can just go ahead and set these XY coordinates in the dungeon equal to a floor character. So we'll say dungeon XY equals floor character. Okay. Then once we have done that, we can go ahead and we can just break out of the loop. And this is going to break out of our attempts loop, because if we have placed a room, we don't need to try and place that room anymore. So that's going to break out of our attempts, and then we'll go to the next room. Okay, so then before we do anything else, we need to return our rooms back to our caller. So let's go ahead and go down to the end of this first for loop. Make sure we're outside of it, and then we will return our rooms. Okay, so let's go ahead and go back up to generate dungeon, and we will create a list of rooms, and we'll call this rooms, and we'll set this equal to generate rooms, and then we'll make sure that we pass in our dungeon. Perfect. So now that we have that, we'll go ahead and get our rooms visualized onto our tile map in our scene. So to do this, we're going to create an overload function for our paint floor tiles in our dungeon visualizer. So let's go ahead and open up our dungeon visualizer. And here is our paint floor tile. So just above it, we're going to create another paint floor tile. So say public void paint floor tiles. And instead of passing in a hash set of floor positions, we're going to pass in our dungeon, which is a 2D character array. And then we're also going to keep that optional parameter. So we'll say bool generate walls equals true. Okay, so then inside of this new overload method, we're going to go ahead and loop through all of the positions in our dungeon. So we'll say for int x equals 0, and then we'll loop until we reach our dungeon width. So to get that, we're going to say dungeon.getLength, and then we'll use our first length, so that's will be 0, and then we'll increase our x. And then we're going to loop through our y positions as well. So say int y equals 0, and then y is less than dungeon.getLength, and this will be our get length of 1, which is our y, and then we'll increase our y. So now that we have the loop, we're going to calculate our position, and then we're going to paint our tile at that position. So first, let's go ahead and update our paint tile function. Right now, it's using this tilemap.world2cell to calculate the tile map position, which is causing the dungeon to be far away from 0, 0. And I don't really want to do that because it sometimes creates an error that like we're really far away from like the camera. So instead, we're just going to use like 0, 0, and then whatever position in our grid. So we'll go ahead and just like delete this whole line. And instead of passing in our tile position, we're just going to pass in our position. And then we will update this to be a vector3 int. And that's going to cause an error here, but we'll just cast this to a vector3 int there. And then again, we'll have one down here. So this will just need to be cast. Okay. And that will allow us to choose a index, a z index if we want to. And then we pass our position, pass our tile, we're good to go. So back up in our overload of our paint floor tiles, we're going to go ahead and calculate our position. So we'll create a vector3 int, and then we'll just say tile position. And that's just going to equal a new vector3 int at our x, y, and then of course 0. And then once we have that, we're going to check if our if we're in a floor tile or if it's a wall tile, because we only want to paint floor tiles here. So we can actually go if, and we'll do this above our tile position because we're going to want that to be inside of our if statement, because we don't really need to know what position we're in if we're at a wall. So we'll just put this above. So if dungeon x, y equals, and then we'll just kind of hard code this for now. We'll come back and we'll update this. We'll find a way. And then we're going to take our vector3 and we'll put this in here. So if we are a floor tile, then we'll go ahead and calculate our tile position. And then once we've calculated our tile position, we can go ahead and call paint tile. Right, so then we'll pass in our tile position, we'll pass in our floor tile map, and we'll pass in our floor tile. Perfect. And we also want to include this generate walls thing. So for now, we'll just add the if statement for it. So if generate walls, and then we're not going to call this yet, but we will. So we'll come back to that. So we'll save. All right. So then let's go ahead and update our dungeon generator to have a reference to our visualizer again. So just after our max room size, we'll say public dungeon visualizer, and we'll call it dungeon visualizer. And then in our generate dungeon function, we can go ahead and just call our new paint floor tiles method. So we'll just pass in our dungeon. And then we don't need to pass in anything else for our generate walls because it's not going to do anything if it's true. It's just going to hit that if statement, and then there's no code, so it won't do anything. But if you want to, you could say false so it doesn't hit it, but nothing's going to happen. So we're just going to leave it like this. And then also before we call our paint floor tiles, let's also make sure that we call our clear, just to make sure that anything that's currently on our tile map gets cleared out before we try to paint some new tiles. Okay, let's save our script, and we'll go ahead and head back to Unity. Let's compile. Perfect. And we'll go ahead and go to our dungeon generator, and we'll see all of our new parameters here. And we still have our visualizer, which looks great. So let's go ahead and click our generate dungeon button, and that's going to generate our rooms for us. So here you can see all the rooms that were generated. So we've got a room here, and then we have a room that's like right next to it. And then we have all of our other rooms are not connected this way. But do know that these two are separate rooms. So when we select our starting room and exit room in the next video, these are possibly, it's going to look like one room, but it is two different rooms. And there'll probably be like a little connection like this. All right, so now that we have our rooms generated, let's find a way to connect our hallways. So let's go back to our script. And we will create a function called connect rooms. So let's go ahead and go to the bottom. We'll add a private void. Call this connect rooms. And we have our char dungeon that we'll pass in. And then we'll also need our rooms list, so we'll pass that in as well. Okay, so now that we have our connect rooms function in here, we're going to need a way to calculate the center of our room. So let's go ahead and add a function in our room to just return this for us. So create a public, and then we're going to return a pair. So we'll say a pair of int, and then we'll call this center. And in here, we're just going to return the calculated center of our room. So we'll say return. And then I'm going to add the parentheses in there for the pair. And then for our x, we can determine our x center by taking our current x position. So that'll be the leftmost of our room, plus the rightmost of our room, which is going to be our width. And then we'll divide that by 2, and that will give us the center of our x. And then we'll do the same thing for the y. So our bottommost y plus our topmost y, and divide that by 2. Perfect. So that's our center. So let's go ahead and head back to our dungeon generator, and we'll go ahead and get our room center. So first we're going to loop through all of our rooms. So we'll say for int I, and then we're actually, instead of starting at our first room in our list, we're actually going to start at the second room. And this is because we're going to check the room before us and ourselves, and we're going to see if we can connect them. So we don't want to start at 0, because if we start at 0, there's no room before us. So we'll just start at 1. And we're going to keep looping until I is less than our rooms.count. And then we'll just increase our I. Okay, then we will get the room centers that we need. So we'll say var x1, y1, and this is going to be the room before us. So we'll set that equal to rooms I minus 1 dot center. Okay, and then we'll get our current rooms. This will be x2, y2, rooms I dot center. Okay, once we have a room center, we can go ahead and pick a random number between 0 and 1 to determine if we're going to do horizontal corridors first or if we're going to do vertical corridors first. So we'll say if random, and then we actually also need to define a random first. I forgot to do that at the top, so let's do that now. So we'll say system.random, we'll call it random, equals a new system.random. And then now we can use our random.next to determine between 0 and 2 which number it's going to want. And if this is a 0, we will do horizontal corridors first. And if that is not true, then we'll do our vertical corridors first. All right, so let's go ahead and create some functions for this. So at the top here, we'll say create horizontal corridor. And we'll copy this and paste it here. And then also down here. And then instead of horizontal for this bottom one, we're going to call it vertical. Then we can copy and paste this line, and we'll copy it and paste it right above the horizontal. So if this is 0, we'll do horizontal first, then vertical. And then if it's the other way around, if else, we're going to do vertical first and then horizontal. So in order to calculate our corridor, we're going to need to pass in some information for each of these functions. So for our horizontal corridor, we need to pass in our dungeon. And actually, we need to pass in our dungeon for all of them. So let's go ahead and add that to each of these function calls. Okay, and then specifically for a horizontal function, we're going to need to pass in the x value of the room, of our first room, and the x value of our y room. So this is going to be our position. So this will be the x, the center x of each of those rooms. And then because we're moving horizontally, we can just stay on the same y as we'll just use our first room for that. And then for our horizontal call down in our else statement, we'll just copy these add our comma, and then paste them. And for our y, so for our vertical one, we're going to need our y position. So we'll say y1, y2, and then we'll use our x1 here. And let's go ahead and copy those. I'm going to include the comma, and we'll just click and paste. Great, so now we can go ahead and generate our function. So we'll use our command period command, and then we'll use this quick fix generate method horizontal corridor, and we'll do the same thing for our vertical, and that'll generate our methods for us. So I'm going to move the horizontal one above the vertical one, just because we're going to work on that one first, and I like it to be in the order that we're going to work on it. We'll delete our exceptions from both of these so we don't get any errors. And then we're going to rename our last y and x in each of these. So I'm just going to take off the 1, and it's just going to be y. All right. So now we're going to figure out what our start x is in our horizontal. So we'll create an integer to hold that, and we'll call this start. And we're going to use our math.min function to get the minimum of our x1 and our x2. So this will just return the smallest of those two values. And then we'll use our end the same way. So we'll say math dot, instead of min, we'll do max, and we'll do this for x1 and x2. Then once we have those values, we can go ahead and loop through each of the values between those two. So we'll do that by saying for int I equals start, and we'll loop until I is less than or equal to end, and then we'll just increase I. Then we can go ahead and set the position of the dungeon to be a floor position. So we'll go ahead and we'll say dungeon, and then instead of x, we're using I, and then we'll use the y coordinate that we passed in, and this will be equal to our floor character. So that's going to add our floor to our horizontal corridors. And then we're going to use the same logic for the bottom. So to go on our vertical corridor, oops, I forgot that I. All right, and then instead of using our x1 and x2, we'll use y1 and y2. So we'll update our min and our max. And then the only thing we'll need to do then is switch our y and our I. So we'll say, instead of y, we're using x. So we'll say x, and then we'll say I. And that's going to create our vertical corridor. Okay, so now that we've got that finished, we can go back up to our generate dungeon function, and we can tell our dungeon to generate or to connect our hallways. So let's make sure that we do that after our generate rooms. We'll say connect rooms, and then we'll pass in our dungeon, and we'll pass in our rooms list. Okay, so now we can go back to Unity and test it out with no changes needed. We don't need to update anything because it's going to update our dungeon grid, and that is what's used to generate our floors. So if we click generate dungeon, we'll now see that we've got some hallways. But the hallways don't seem exactly correct, so let's go ahead and just make sure we've got our code correct in our connect rooms function. So let's go ahead and head back, and we'll go down to connect rooms, and we've got our random. Though I'm not sure. Oh yeah, for our random.next. Okay. So then we have our loop. So we're going to loop from I equals 1 to our rooms count, then increase. Then we're going to get the center of our room. So let's just make sure that our center of our room is being calculated correctly. So let's go ahead and take a look at our room script. And for our center, we got public center. So returning an int. And we have x plus width divided by 2 and y plus height divided by 2. So that seems correct. Okay, we'll head back to our connect rooms function, and we will take a look at the rest of our code. So we've got x1, y1, rooms I-1 dot center. That's correct. And then x2, y2, rooms I dot center. That looks correct. If it is... All right, so let's go ahead and check our logic for horizontal corridor. So we'll use our start. So we'll use our math min to get between our x and our y, or x1 and x2. And then our end, we'll choose the max of our x1 and x2. And then we say for int I start, I is less than or equal to end, I plus plus, that's correct. Dungeon I, y equals floor char. All right, that is also correct. So then let's double check that we have our vertical one correct. So we're using our y1, y2, y1, y2. And then we're using the same. Okay, so this does look correct. Let's make sure that we're passing the correct things into these. So we should be passing our x1 and x2 as our x's and then our y1. Okay, I see what I did. I messed up. So instead of using x1 here, we need to use our x2 value instead because we're using our second room here. Okay, and then we'll save and we'll try that again in Unity, and this should correct the error. So we'll generate our dungeon, and now our rooms are connected. So we're just passing in the wrong value there. Okay, my mistake. So now we've got a bunch of rooms connected by hallways. Cool, and let's go ahead and adjust some of our dungeon settings so we can get a feel for how this is going to work. We can go like this. We can even make our room size bigger, so we can be like 5 and 10. And then we'll get different configurations. Can make this 100 and like, let's do like 70. And that'll make our dungeon like really spread out. We can tell it to do a lot more rooms. So we could do like 20 rooms. We can make them a lot bigger. So we can say like between 15 and 30. So we'll be able to, or we can keep them small, so between 5 and 10, and we'll end up with like a ton of little rooms interconnected. So you can go ahead and play with this any which way you would like. I found that I really like the dungeon to be at 30-30 with about 8 rooms, and then I'm going to keep the 3 and 7 here, and we'll end up with like a really nice small dungeon. It's got some cool layouts. Okay, so now that we've got our floor and our hallways visualized, let's go ahead and update our wall generator so that way we can also get our walls in there. So to do this, we're going to go ahead and open up our wall generator script. So let's go ahead and we'll open up our file structure, find our wall generator, and then we've got that. Let's go ahead and create an override for our generate walls. So we'll go ahead at the top here and we'll create a new public void generate walls. Oops. Okay, so this is an override function. And we're going to need our dungeon, so we'll pass in our character array. And we also need our dungeon visualizer. Okay, so now that we've got that, we can go ahead and get the dungeon height and width from our dungeon. So we'll say dungeon width equals dungeon.get length 0, and we'll get our height. So let's get length 1. And then we're going to go ahead and loop through all of the positions in our dungeon. So say x equals 0, and then x is less than dungeon width. We'll increase our x. And then we'll loop through all of our y positions as well. Y is less than dungeon height, y plus plus. Okay, so then we're going to go ahead and create our bit mask for each of the neighbors in our dungeon. So first we'll add our string, just like we did before. So we'll say string binary tile type We'll set that equal to an empty string. And then we're going to go ahead and loop through all of our directions. So we'll say for var direction in directions. Oh, and that should be a for each, not a for. Just using so many fors that I got in a groove there. Okay, so then we'll calculate our neighbor's x and y positions using integers. So we'll say neighbor x equals, and then we'll use our x plus our direction dot x. And then we'll use our neighbor y. Oops. And this will be our y plus our direction dot y. Okay. So then we'll check to see if our neighbor is in bounds of our dungeon. We didn't need to do that before, but now that we're using a two-dimensional array, it's very likely that some of these neighbors will not be valid. So we will create a Boolean called is in bounds. And we're going to set this equal to our checks to make sure that our neighbors are in bounds. So first we'll check neighbor x, and we'll make sure that this is greater than or equal to 0. And then we'll check neighbor x again to make sure that it is less than our dungeon width. Okay, and then we're going to check our neighbor y to make sure that it is greater than or equal to 0. Oops, and then I forgot my and signs. And then we'll check neighbor y again to make sure it is less than our dungeon height. Oops. Okay, so if all of those are true, then we do have a tile that is in bounds. So we'll say if is in bounds. Then we're going to go ahead and set up our check for our binary type. So we're going to check if our dungeon at our x and y position is not our current x, our neighbor x and our neighbor y. We're going to check to see if this is a floor tile. And if it is a floor tile, we're going to add to our binary tile type a 1. And then we can go down here and we'll say else. So if this is not a floor tile, we're going to add a 0. Oops. Okay. So now that we've got that, we'll go ahead and we will check if our current tile is a floor tile. So make sure that we are after this for each loop here. And we will say if dungeon x and y equals our floor tile character, or not floor tile, our wall tile character, then we're going to go ahead and calculate our tile position. So we'll say vector3 int tile position equals a new vector3 int, and this is just going to be our x and y and 0. Then we'll go ahead and use our get wall tile function to return the wall tile that we should use. So tile base tile equals get wall tile. We'll pass in our binary tile type. And then we can use our dungeon visualizer to add our walls to our tile map. So let's go ahead and say dungeon visualizer dot paint wall tile. And then we're going to go ahead and pass in everything that we need to pass in for this. So this is going to be our tile position and the tile that we want to use. However, I think this is expecting a vector2 int, so let's just go ahead and cast that for now. Okay. And then let's go ahead and call the generate walls function from our dungeon visualizer. So inside of our if generate walls that we had earlier, we'll say wall generator dot generate walls, and then we're going to pass in our dungeon, and we'll pass in our self as the dungeon visualizer. Okay, so then let's go ahead and head back to Unity and test it out. Like, make sure you got everything saved. We'll go to Unity, and then we'll click our generate dungeon button once everything's loaded. Okay, so generate dungeon. You can see that we have our walls generated now. There's actually a few places in here that they're not generating. This is just because they're missing in our bitmap, since this is going to generate some configurations that are different than our previous one. So what you'll want to do for these is just kind of go through, figure out their bitmap, and then put that into our wall tile helper and set up our get wall tile to include those. Okay, like so for this one, it needs like a connection, and then this is just an interior wall. And same here. And then as well as here. So there's going to be some testing involved in making sure that all of our wall tiles are showing up properly. But really, this shouldn't take too long. It's just some bitmaps that are missing. All right, so you've successfully implemented our new dungeon generation algorithm. So great work. And in our next video, we're going to be closing our gameplay loop even further by selecting a random starting room and exit room. Then we'll go ahead and generate a new dungeon and spawn our player at the new starting room. If you like this video, please like and subscribe, and don't forget to hit that notification bell so you won't miss our next video. I'll see you next time.